All right, so today we're going to dive into something, that most people probably don't think about too much.
Right.
It's software testing.
Yeah.
I mean, we use software every day, right?
Right.
Like all the time.
Yeah. Every single day.
But how often do we think about what goes into making sure that it works?
Yeah. That's
So,
true.
the
The average person, probably doesn't give much thought to all those people
Yeah.
working behind the scenes to, prevent those annoying bugs.
Right.
And, just making sure that your digital experience is good.
Yeah,
It's
exactly.
a smooth process.
That's what we're here to talk about today.
Yeah.
And we're going to unpack 7 principles of software testing with examples.
Absolutely.
And trust me, this is way more interesting than it might sound at first.
It is very interesting.
So these principles are really like the foundation for how people who develop software and test software,
That's right.
how they approach their work.
Yeah.
And by understanding these principles, you can gain a whole new appreciation for just how complex
Absolutely.
software development really is. Yeah. So principle number 1
Okay.
throws us right into the deep end, right off the bat.
Right.
Exhaustive testing
Yes.
is impossible.
Impossible.
Right,
So
never.
it sounds counterintuitive, I know.
Right.
But just imagine even trying to test every single possible scenario
Yeah.
for like a really simple task, like let's say moving a file
Okay.
from one folder to another.
Yeah, I can already see where this is going.
Like what if the file is open?
Oh, yeah.
Or what if the destination folder is full?
Mhm.
Or you don't have permission to paste it there?
What if the file is too big
Too big, yeah.
to even fit?
Absolutely. There's so many different things.
Thank
It
you
just
for-
explodes
Yeah.
the number of potential scenarios. It grows exponentially,
Yeah,
even with a simple task like that.
right.
So now magnify that to the scale of like a really complex software system
Yeah.
with thousands of features,
Yeah.
interactions, and all this stuff. It just becomes clear that testing every possibility is just not feasible.
So how do they even begin to tackle this?
Yeah.
It sounds pretty daunting.
It is daunting, but that's where risk assessment comes in.
Okay.
So instead of aiming for this impossible goal of testing everything,
Right.
developers have to prioritize their efforts.
Okay.
So they focus on the areas
Uh-huh.
that are most likely to have problems,
Okay.
the areas where the consequences of a bug would be the most severe.
So it's all about strategically focusing resources
Exactly.
where they'll have the biggest impact.
Yeah, it's all about strategy. You have to
Okay.
think about it like
Yeah.
when you're testing an operating system,
Yeah.
you're likely going to focus a lot more on the multitasking capabilities
Well-
because that's a complex area
Sure.
where errors are more likely to occur.
Uh-huh.
So you would prioritize testing scenarios where you have, multiple programs running simultaneously,
Right.
pushing that system to its limits.
Okay, so focus on those most critical areas.
Yeah.
Helps manage this sort of like
It does.
overwhelming nature of testing every single.
Exactly. You can't test everything, so
Yeah.
you have to pick your battles.
Okay, so this focus on prioritization leads us to the next principle,
Okay.
which is defect clustering.
Defect clustering, yes.
So this principle is fascinating to me
Yeah.
because it reveals a pattern
Yeah.
in how software defects tend to appear.
Yeah. It's pretty interesting.
So it's based on the Pareto principle,
Yeah.
the 80-20 rule.
Right. 80% of the effects
Right.
come from 20% of the causes.
Exactly. So
Yeah.
applied to software.
Yeah.
This means that a small number of modules
Yeah.
or components
Yes.
tend to contain the majority of the defects.
Exactly.
Like, it's like if you lose your keys,
Uh-huh.
they're always in the same few places, right?
Yeah.
You kind of learn to focus your search
Exactly.
on those high probability areas.
Yeah. You know where to look.
Does that mean that certain parts of the code are just like inherently more prone to bugs?
Well, it's not necessarily that the code itself is flawed,
Okay.
but rather that certain areas are just more complex or
Uh-huh.
they have a higher degree of interaction with other parts of the system.
Okay.
So that makes them more susceptible to errors.
So it's kind of like a chain reaction almost.
It can be, yeah.
Okay, so as a software developer,
Yeah.
you should remember that focusing on fixing the most common bugs
Right.
in those key areas
Yes.
is going to yield the biggest improvement.
Absolutely. That's a great takeaway.
Now, you might think that once you've identified those bug-prone areas,
Yeah.
you can just keep, hammering away at them
Right.
with the same tests over and over again,
Yeah.
and eventually you'll catch all the problems.
Yeah, you would think so, but it doesn't quite work that way.
So it's not just about where you test, but how you test.
Exactly. How you test.
Okay.
So this is where we encounter the pesticide paradox.
Okay, the pesticide paradox.
Yeah, so the idea is that if you keep using the same tests, like the same pesticide, eventually the bugs, like insects, will develop a resistance,
Okay.
and they'll adapt and find ways to slip through the cracks.
I love that analogy. That makes
Yeah.
perfect sense.
It's a good one.
But isn't there a risk of going too far in the other direction?
Yeah.
Like if you're constantly changing the tests,
Right.
even when they're working well,
Yeah.
could that lead to like inefficiencies?
Yeah, it's true.
It could.
It's a delicate balance.
Right.
So we have to constantly evolve our testing methods, add new test cases, which are specific sets of conditions and inputs that are used to evaluate the software.
Okay.
And we have to approach the problems from different angles to
Right.
uncover those sneaky hidden defects.
So it's like this constant game of cat and mouse
Exactly.
between the testers
Yeah.
and these bugs.
It is, yeah. It's a constant back and forth.
That's pretty cool.
It is.
And that actually kind of highlights the fact that testing can only really show the presence of defects,
That's right.
not their absence.
Yeah, you can't prove a negative.
Right.
Just because you don't find any bugs during testing doesn't mean they aren't lurking somewhere in the code,
Oh, yeah.
waiting to, rear their ugly heads.
Waiting for the perfect moment to just totally ruin your day.
Yeah, it's
So
always a possibility.
even with the most rigorous testing, there's just no guarantee that everything's been caught.
Right. Yeah, there's no way to be 100% certain. It's kind of like trying to prove a scientific theory.
Okay.
You can conduct all these experiments,
Yeah.
gather all this evidence to support it, but you can never definitively prove
Yeah.
that there's not a single exception out there.
Right.
A single case that might disprove the whole thing.
Yeah, one little outlier.
Yeah, that one little thing that could throw everything off.
So I guess this is where the expression absence of evidence is not evidence of absence comes in.
Exactly. That's a perfect way to put it.
So how does this idea of never being 100% certain
Yeah.
apply to software development as a whole?
Well, it brings us to another important principle,
Okay.
one that's often overlooked.
Uh-huh.
It's the absence of error fallacy.
The absence of error fallacy.
Yeah, so this fallacy assumes that just because the software appears to be bug-free, that it automatically means it's a good product.
Oh, so it overlooks
Yeah.
like the user experience part.
It does, yeah. It overlooks whether the software actually meets the needs of the users.
So it's kind of like, you have this perfect spreadsheet
Okay.
with all the right formulas
Yeah,
and no errors,
right.
but it's actually tracking completely useless data.
Exactly.
Technically perfect,
Yes.
but practically worthless.
Totally worthless. Yeah, it's a good analogy.
So it might be bug-free,
Yeah.
but if it's, clunky, confusing, or doesn't solve the problem
Exactly.
it was designed to address,
Okay.
then it's, failed.
It's failed in a fundamental way. Yeah.
I'm starting to see how these principles aren't just about,
Yeah.
the technical details.
Right.
They actually speak to,
Yeah.
the bigger picture
They do.
of creating software that people actually want to use.
Exactly. It's about the user experience, ultimately.
So how do developers go about avoiding
Yeah, that's a good question.
this absence of error trap?
Well, this is where the principle of early testing comes in.
Early testing.
Yeah, so it's far more effective
Okay.
and less costly
Right.
to catch those errors early in the development process
Okay.
during the, the design and planning stages
Well.
than it is to try to fix them after the software is already built.
So instead of waiting until the whole cake is baked,
Yeah,
and then realizing you forgot the sugar,
right.
it's better to check the recipe and ingredients beforehand.
Actually, check everything before you start baking.
What are some of the ways developers test
Well,
early on in the process?
there are lots of different strategies,
Yep.
but two common ones are unit testing
Unit testing.
and integration testing.
Okay.
So with unit testing, developers test individual components of the software
Oh.
in isolation
Uh-huh.
to make sure that each part works as intended.
Right.
Integration testing
Okay.
checks how those individual components interact with each other,
Right.
looking for problems that might arise when they're all combined.
God.
So it's kind of like...
So it's like making sure each ingredient in the cake tastes good on its own.
Yeah.
But then also making sure that all the ingredients work together.
Exactly.
To create that delicious final product.
Yes, it's all about the final product.
And speaking of final products, isn't it about time we revisited that Windows 98 story?
Oh, yeah.
The one where even Microsoft couldn't escape.
Yeah.
Those bugs.
Nobody's perfect. Right. Even Microsoft.
So set the scene for us.
All right. So
we've got Bill Gates on stage.
Yeah.
The excitement is palpable. Everybody's waiting with bated breath to see what's going to happen. What happens next.
So Bill is demonstrating the new plug-and-play functionality of Windows 98.
Okay.
He's about to connect a scanner to the computer. Seemingly simple task, right?
Yeah.
Everyone's watching with anticipation.
Yeah.
And then, bam!
The blue screen of death.
The dreaded blue screen of death.
I bet there were some drop jaws in the audience.
Oh, I'm sure there were.
Maybe even a few sighs of relief over at the Apple camp.
Oh, bubbly.
But, beyond the awkwardness of that moment, that incident really drives home a crucial point.
It does.
Right? It really does. It kind of shattered this illusion of software perfection.
Yeah.
It reminded everybody.
Right.
Even the tech giants.
Even Microsoft.
That bugs can happen.
Yes.
And they can happen at the most inconvenient times.
Yes, they can.
It also highlights how the context of the software being tested plays a really critical role.
It does.
And speaking of which, that brings us to our final principle for today.
Okay, let's hear it.
Which is that testing is context dependent.
Context dependent, yes.
So this principle emphasizes that there's no one-size-fits-all approach to software testing.
Exactly.
The way you test a mobile game
Yeah.
is going to be very different from how you test a medical device.
Completely different.
Or a financial system.
Very different, yeah.
The risks are different.
The risks are huge.
The consequences of failure are different.
Absolutely.
User expectations are different.
It's all different.
Yeah.
You have to tailor your approach to each situation.
While those 7 core principles give us a solid foundation.
Yeah, good starting point.
The specific testing strategies need to be tailored.
They do.
To each unique situation.
Yeah, you have to be flexible.
That makes a lot of sense.
It does.
That brings us to the end of our exploration.
All right.
Of these 7 principles of software testing.
Very interesting stuff.
Hopefully you've gained a deeper appreciation.
Yeah.
For the work.
The intricate work goes into making the software we use every day.
It's fascinating to think about how these seemingly technical principles actually touch on broader themes like user experience and risk management.
Absolutely.
And just this constant pursuit of improvement.
Yeah, it's a never-ending process.
In the ever-evolving world of software development.
That's right. It's always changing. It's an exciting field to be a part of.
For you, the listener, what does all this mean?
Yeah, good question.
The next time you encounter a bug, which, let's face it, we all do.
We all do. It's inevitable.
Will you see it differently?
Maybe.
Instead of frustration?
Yeah.
Will you feel maybe a little bit of understanding?
It's possible.
Or recognition of the complex dance between human ingenuity and this inherent unpredictability.
The unpredictability of software,
Of software.
It's always a bit of a mystery.
Maybe even a little bit of appreciation.
Yeah.
For the unsung heroes.
Those software testers,
The software testers.
Working tirelessly behind the scenes.
Yeah.
To minimize those glitches and create a good experience.
Yeah. To create a seamless digital experience for all of us.
Exactly.
Well said.
Thank you.
And with that, dear listeners.
Yes.
We've reached the end of our deep dive into the fascinating world of software testing.
It's been a good one.
Hopefully you've surfaced with a newfound understanding of these intricate processes and principles that govern this often invisible but crucial aspect.
Very important.
Of the digital world.
Absolutely.
Remember, the next time your app crashes or your computer throws a tantrum, take a deep breath.
Take a deep breath.
And remember, it's all part of the journey.
It is. It's all part of the process.
And who knows? Maybe you'll even be inspired to learn more about this amazing world of software development.
It's a fascinating world.
Until next time.
Yes.
Keep exploring, keep questioning.
You keep learning.
And keep diving deep.
Dive deep.
All right, so we're going to get into something a little different today.
Okay.
But I think it's going to be just as interesting.
I'm sure will be.
As our previous deep dives.
I'm ready.
We're going to be talking about a topic that's near and dear to my heart.
Okay.
It is near and dear to my heart.
I'm intrigued.
It's the 7 principles.
7 principles.
Of software testing.
Oh, interesting.
And
software testing.
We're going to be looking at those through 7 principles of software testing with examples.
Okay, so we've got a good source there.
We've got a great source.
Excellent.
And I think a lot of people, when they hear software testing, they think, oh, that's not very interesting.
Right, it sounds a little dry.
Yeah. But I think that after we unpack these 7 principles, you'll see that it's actually way more interesting.
It is.
Than it might sound at first.
Absolutely.
So.
The first principle.
Okay. The first principle, hit me with it.
That exhaustive testing.
Exhaustive testing.
Is impossible.
Impossible.
Now that might sound kind of...
Yeah, that's a bold statement.
Counterintuitive, right?
It is, yeah.
Because you would think...
You would think.
Well, if you're testing software...
Yeah.
Shouldn't you test...
Every possible scenario.
Everything.
Yeah, that's the ideal, right? But in reality, it's just not possible.
Okay, why is that?
Well, let's think about even a simple task, like moving a file from one folder to another.
Okay, yeah.
Think about all the possible scenarios.
Right.
What if the file's open?
Okay, yeah, that's one thing. What if the destination folder is full?
Okay.
What if you don't have permission to paste it there?
Yeah. What if the file is corrupted?
What if the file's corrupted? Yeah, exactly.
What if the file name is too long?
Too long, yeah. The list goes on and on.
The possibilities is kind of endless.
They are, yeah.
So
even with a simple task like that, the number of potential scenarios just explodes.
Yeah.
It grows exponentially.
Right.
Now imagine magnifying that to the scale of a complex software system with thousands of features and interactions and...
I mean,
that's mind-boggling.
It's basically every piece of software that we use.
Pretty much, yeah.
It's mind-boggling.
So it quickly becomes apparent that testing every single possibility is just not feasible.
So how do software developers even begin to tackle this?
Well...
It just seems so overwhelming.
It is overwhelming. That's where the concept of risk assessment comes in.
Okay, risk assessment.
Yeah, so instead of aiming for this impossible goal of testing absolutely everything, developers have to prioritize their testing efforts.
Okay.
So they focus on the areas that are most likely to have problems.
Okay.
The areas where the consequences of a bug
would
be the most severe.
So it's all about strategically focusing those resources where they'll have the biggest impact.
Exactly.
Like choosing your battles.
Choosing your battles, yes.
So for example, if you're testing an operating system, you would probably focus more on its multitasking capabilities.
Exactly.
Because that's where a lot of things can go wrong.
Exactly. It's a very complex area.
You're running multiple programs at the same time.
Yeah, a lot of things can go wrong.
So
you prioritize testing scenarios where you've got multiple programs
running simultaneously.
Yeah.
Really pushing that system to its limits to see if it can handle it.
So focusing on the most critical areas helps manage this sort of like, overwhelming nature of testing everything.
It does, yeah.
Okay, so this focus on prioritization leads us to the next principle, which is defect clustering.
Defect clustering, okay.
So this principle, I find it really fascinating.
It is interesting.
Because it reveals a pattern in how software defects tend to appear.
It does, yeah.
And it's actually based on the Pareto principle.
The Pareto principle, yes.
Which is the 80-20 rule.
The 80-20 rule, that's right.
80% of the effects come from 20% of the causes.
Exactly.
So applied to software, this means that a small number of modules or components tend to contain the majority of those defects.
Yeah. It's interesting how that works out.
So it's almost like if you lose your keys...
They're always in the same few places.
You always check those same places first.
You check the same places. You know where to look.
Exactly.
So you focus your search on those high probability areas.
Go right to the most likely spots.
Now, does this mean that certain parts of the code are just inherently...
Well, that's a good question.
More prone to bugs than others?
It's not necessarily that the code itself is flawed. But rather that certain areas are just more... complex, or they have a higher degree of interaction with other parts of the system, and that makes them more susceptible to errors.
It's kind of like a chain reaction.
It can be, yeah. One little error can lead to a cascade of problems.
So for you as a software developer, you should remember That
yes,
focusing on fixing those most common bugs in those key areas is going to yield the biggest improvement.
Absolutely. That's a key takeaway.
Now, you might think that once you've identified those bug-prone areas, you can just keep hammering away with the same tests over and over.
Right. You'd think so, wouldn't you?
And that's how you catch everything.
But it doesn't quite work like that.
So it's not just about where you test.
Yeah.
But it's also about how you test.
It's about how you test. Exactly.
Okay, so tell me about that.
Well, this is where we encounter the pesticide paradox.
The pesticide paradox.
Yeah. So the idea is that if you keep using the same tests over and over again, the bugs will eventually, it's like they develop a resistance to it.
They get used to it.
Yeah, they get used to it. They adapt.
Okay.
They find ways to slip through the cracks.
So it's kind of like if you keep using the same pesticide.
Exactly. That's where the name comes from.
Okay.
The insects will eventually become immune to it.
Oh, that's a great analogy.
Yeah, it's a good one.
But then is there a risk of going too far in the other direction?
Yeah.
And constantly changing the tests.
Right.
Even when they're working well.
Yeah, there is a risk.
Because wouldn't that lead to inefficiencies?
It could, yeah.
Okay.
So it's a delicate balance. You have to constantly evolve your testing methods.
Okay.
Add new test cases.
What are test cases?
Test cases are specific sets of conditions.
Okay.
And inputs that you use to evaluate the software.
Okay, so you got to switch it up.
We have to switch it up, yeah.
You got to keep the bugs guessing.
Exactly. Keep them on their toes.
Okay.
And you have to approach the problems from different angles to uncover those sneaky hidden defects.
So it's like this constant game of cat and mouse.
It is, yeah. It's a constant back and forth.
Between the testers and the bugs.
The testers and bugs, yeah.
That's pretty cool.
It is a fascinating field.
And that kind of highlights the fact that testing can only show you the presence of defects.
That's right.
It can't show you the absence of defects.
You can't prove a negative.
Right.
Just because you don't find any bugs during testing, it doesn't mean that they aren't there.
Right.
Lurking somewhere in the code.
They're hiding.
Waiting to rear their ugly heads.
Waiting for the perfect moment.
Exactly.
To strike.
When you least expect it.
So even with like the most rigorous testing, there's no guarantee that everything's been caught.
There's no way to be 100% certain. It's kind of like trying to prove a scientific theory.
Okay.
You can conduct countless experiments. You can gather tons of evidence to support that theory.
But you can never definitively say there's not one little exception out there.
One little outlier that might disprove the whole thing.
So I guess this is where that expression, absence of evidence is not evidence of absence, comes in.
Exactly. That's a perfect way to put it.
Okay, so how does this idea of never being 100% certain apply to software development as a whole?
It brings us to another really important principle.
Okay.
And it's one that's often overlooked.
Okay.
It's the absence of error fallacy.
The absence of error fallacy?
Yeah.
What is that?
So this fallacy assumes that just because software appears to be bug-free, that it automatically means it's a good product.
Oh, so it overlooks.
It does, yeah.
Whether it's actually a good product or not?
Exactly.
Like it overlooks usability.
The user experience, yeah.
Okay.
Does it actually meet the needs of the user?
So it's kind of like that perfect spreadsheet.
Oh, okay.
Right?
Yeah.
With all the right formulas in it.
Right.
And no errors.
No errors. It's technically perfect.
But it's actually tracking completely useless data.
Right. So it's useless.
So it's technically perfect, but practically worthless.
Totally worthless.
I like that.
Yeah. It's a good analogy.
It might be bug-free.
Right.
But if it's clunky and confusing.
If it's hard to use.
Or it doesn't solve the problem it was designed to solve.
Right. Then it's a failure.
Then it's failed.
Yeah. It's failed in a fundamental way.
I'm starting to see how these principles aren't just about the technical details.
Right.
It's about the bigger picture of creating software.
It is.
That people want to use.
It's about the user experience.
So how do developers go about avoiding
That's a great question.
this absence of error trap?
Well, that's where the principle of early testing comes in.
Early testing, okay.
So it's much more effective and less costly to catch errors early in the development process.
Okay.
Like during the design and planning stages.
Okay.
Than it is to try to fix them.
Right.
After the software's already been built.
So it's like, instead of waiting until the entire cake is baked to realize you forgot the sugar, you check the recipe and ingredients beforehand.
Check everything before you start.
So what are some of the ways that developers test early on?
There are many different strategies.
Okay.
But two common ones are unit testing.
Unit testing.
And integration testing.
Okay, so tell me about those.
So with unit testing, developers will test individual components of the software in isolation to make sure that each part works as intended.
Right.
Integration testing looks at how those individual components interact with each other, looking for problems that might arise when they're all combined.
Gotcha. So it's like making sure each ingredient in the cake tastes good on its own, but then also making sure that they all work together to create that delicious final product.
It's all about the final product.
And speaking of final products,
I think it's about time we revisited that Windows 98 story.
The one where even Microsoft couldn't escape the bugs.
Nobody's perfect, not even Microsoft. So set the scene for us.
Okay, so we've got Bill Gates on stage at the big Windows 98 launch event.
Palpable excitement.
Oh, yeah, the energy is electric.
Everyone's waiting with bated breath.
Big launch.
To see what's going to happen.
What's going to happen there?
Next. So Bill is demonstrating the new plug-and-play functionality of Windows 98.
Yeah.
He's about to connect a scanner to the computer. Seemingly simple task.
Yeah, should be easy. Right.
Should be no problem, right?
Everyone's watching with anticipation.
Everyone's glued to their seats.
And then, bam.
Yeah.
The blue screen of death.
The dreaded blue screen of death.
Oh, man. I bet there were some dropped jaws.
Well, I'm sure there were.
In that audience.
A lot of embarrassed faces.
Maybe even a few sighs of relief over at the Apple camp.
Probably, yeah.
But beyond the awkwardness of that moment, that incident really drives home.
It does.
A really crucial point.
It does. It really does.
It shattered the illusion of software perfection.
Yeah, it shows that.
It reminded everyone, even the tech giants,
even Microsoft,
that bugs can happen.
Bugs happen.
And they can happen at the most inconvenient times.
At the worst possible time.
It also highlights how the context of the software being tested really plays a critical role.
Well, yeah, absolutely it does.
And speaking of which, that brings us to our final principle for today.
All right.
Which is that testing is context dependent.
Context dependent.
So this principle emphasizes that there's no one-size-fits-all approach to software testing.
Right, there isn't.
The way you test a mobile game is going to be very different from the way you test a medical device.
Yeah, the stakes are much higher.
Or a financial system.
Right, yeah, totally different.
The risks are different.
The risks are huge.
Consequences of failure are different.
Absolutely.
And user expectations are different.
Totally different. So you have to tailor your approach to each situation.
So those 7 core principles give us a solid foundation.
A good starting point.
But the specific testing strategies need to be tailored.
They do,
to each unique situation.
Absolutely, you have to be flexible.
That makes a lot of sense.
It does.
And that brings us to the end of our exploration of these 7 principles of software testing.
It's been a fascinating discussion.
Hopefully you've come away with a deeper appreciation for the work.
The intricate work that goes into creating the software that we use every day.
It's fascinating to think about how these seemingly technical principles actually touch on these broader themes of seeing user experience and risk management.
Absolutely.
And this constant pursuit of improvement.
Yeah, it's a never-ending process.
In this ever-evolving world.
That's right.
Of software development.
Always changing, always evolving.
So for you, the listener,
what does this all mean?
The next time you encounter a bug, which, let's be honest.
We all do.
We all do.
It's inevitable.
It's going to happen.
It's going to happen.
Will you see it differently?
Maybe.
Will you, instead of frustration, feel maybe a little bit of understanding?
It's possible.
A recognition of this complex dance.
That's right.
Between human ingenuity and this inherent unpredictability.
The unpredictability of software. Yeah.
Software.
It's always a bit of a mystery.
Maybe even a little bit of appreciation. For those unsung heroes.
The software testers.
The software testers.
Yeah, working tirelessly behind the scenes.
Working tirelessly to minimize those glitches. And create seamless digital experience for all of us.
Exactly.
Well said.
Thank you.
And with that, dear listeners. We have reached the end of our deep dive.
Another one down.
Into the fascinating world.
It's been a good one.
Of software testing.
It has.
Hopefully you've surfaced with a newfound understanding of these intricate processes and principles that govern this often invisible.
Yeah, invisible but crucial.
But crucial aspect of the digital world.
Absolutely.
So the next time your app crashes or your computer throws a tantrum, take a deep breath.
Take a deep breath.
And remember, it's all part of the journey.
It is. It's all part of the process.
And who knows, maybe you'll be inspired to learn more about this amazing world of software development.
It's a fascinating world.
Until next time.
Yes.
Keep exploring, keep questioning.
Keep learning.
And keep diving deep.
Dive deep. Yeah, it really makes you think about software development in a whole new way.
It really does.
You know, it's not just about writing lines of code.
Right. There's a whole philosophy behind it.
There is, yeah.
There's a whole way of thinking about it.
And these 7 principles that we've discussed, I think really highlight that, you know, they're not just technical guidelines. They're really a reflection of how developers approach problem solving.
Yeah, how they think about risk.
Risk management.
And this constant pursuit of quality.
Exactly. It's a never-ending pursuit.
So for you, the listener, what does this all mean?
That's a good question.
The next time you encounter a bug.
Yeah.
And we all do.
We all do. It's inevitable.
Will you see it differently?
Maybe. Yeah.
Will you, instead of frustration, feel
maybe
a little bit of understanding?
It's possible.
A little recognition of that complex dance between human ingenuity and the inherent unpredictability.
The unpredictability of software.
It
can be a bit of a mystery sometimes.
Maybe even a little bit of appreciation for those unsung heroes.
The software testers working tirelessly behind the scenes.
The software testers,
Yeah, trying to make our lives easier.
Minimizing those glitches.
Exactly.
And creating a seamless digital experience.
Yeah, smooth experience.
For all of us.
That's the goal.
Well said.
Thank you.
And with that, dear listeners, we've reached the end.
Another one down.
Of our deep dive into
the fascinating
world of software testing.
It had.
Hopefully you've surfaced with a newfound understanding of these intricate processes and principles.
The inner workings.
Yeah, that govern this often invisible.
But
absolutely crucial aspect of the digital world.
Absolutely. We rely on it every day.
So the next time your app crashes or your computer throws a tantrum,
take a deep breath.
Take a deep breath and just remember.
It's all part of the journey.
It's all part of the journey.
The journey of software development.
And who knows?
Yeah.
Maybe you'll even be inspired to learn more. About this amazing world of software development.
It is an amazing world.
So until next time.
Yes.
Keep exploring.
Keep learning.
Keep questioning.
Keep asking questions.
And keep diving deep.
Dive deep, everybody.